teachers and dear students. Today topic is flow measurements. My name is Mr. Arun Kumar Goel, Head of Department Civil, Sant Baba Atar Singh Government Polytechnic Badbar. The topic of this is fluid mechanics, which is in the third sem civil. The topic today is of this fluid mechanics is flow measurements. The various contents today of our topic: first, types of the fluid flow, continuity equation, Bernoulli's theorem, flow measurements, floats, current meter, Peter tube, venturi meter, notches, weirs, and the velocity of approach. First, we take types of flow. Flow is of 10 types. The various types of this flow are steady flow, second one unsteady flow, uniform flow, non-uniform flow, laminar flow, turbulent flow, compressible flow, incompressible flow, rotational flow, and last is the irrotational flow. Now, we will deal one by one. The first one is the steady flow. So, from the diagram, so this is the diagram, this is a conduit, this is a pipe, and the liquid is flowing from this point to this point. The flow is a steady flow, the flow in which the fluid particles, the fluid characteristics like density, pressure, and velocity. There are three characteristics of first is known as density, pressure, and velocity. At a point do not change with time is known as steady flow. Suppose there is the point A, then we say about the point B, then we say at the point C. We take the fluid characteristics, the three characteristics like density, pressure, and velocity. With respect to the time that does not change, means that mathematically we can explain dV divided by dt is equal to 0, means that it does not change. Then we say pressure, dP divided by dt is equal to 0, and then we say as this density, that is d rho. This symbol is for rho. Rho means density of the liquid. So, d rho divided by dt is equal to 0. So, we say that the fluid characteristics like density, pressure, and velocity at a point do not change with time is known as steady flow. Then secondly, unsteady flow. Unsteady flow means the flow in which the fluid characteristics, there are three characteristics, properties of fluid: density, pressure, and velocity. In this case, the fluid characteristics like density, pressure, and velocity at a point changes with time is known as unsteady flow. So, unsteady flow को हम explain करते हैं mathematically. dV divided by dt is not equal to 0, then dP divided by dt is not equal to 0, and d rho, this symbol is rho, then d rho divided by dt is not equal to 0, means there are the changes at point of the three characteristics of the fluid like density, pressure, and velocity. So, the flow in a pipe whose value is opened or closed gradually is an example of unsteady flow. So, example of unsteady flow is flow in a pipe whose valve is opened or closed gradually is an example of unsteady flow. Then we come to the uniform flow. So, this is a pipe, so this is a conduit, and the liquid is flowing from this to this way. So, the uniform flow is defined as that type of flow in which the velocity at any given time does not change with respect to space. So, mathematically we can explain dV divided by ds at any time is T is constant is equal to 0. The flow through a straight pipe of constant diameter will be a example of uniform flow. So, uniform flow means there is a pipe of uniform size, liquid is flowing and the flow is known as is defined as a uniform flow in which the velocity at any given time does not change with respect to the space. Means that dV divided by ds when time is constant must be equal to 0. Then we come to a non-uniform flow. So, non-uniform flow is defined as that type of the flow in which the velocity at any given time changes with respect to the space. So, mathematically we can say dV divided by ds when time is constant is not equal to 0. So, dV divided by ds is not equal to 0. Example है इसके, the flow through a straight pipe bend or canal bend will be a example of a non-uniform flow. So, non-uniform flow means is defined as that type of the flow in which the velocity at any given time changes with respect to the space. Means dV divided by ds at time is constant is not equal to 0, then it is not non-uniform flow. So, non-uniform flow की example है of a straight pipe bend, or canal bend with which is an example of a non-uniform flow. Then we come the laminar flow. Now, this is a conduit, this is a pipe of a uniform size and the liquid is flowing just like this is known as laminar flow. So, laminar flow means the flow in which the fluid particles move in layers. So, these are the layers. So, the particles they are moving in layers, and do not cross the path of the other particles. They are not moving this like this, they are moving in the straight line, they are moving in the layers. Then this is known as a laminar flow. This is an example of a laminar flow. The flow through a capillary tube or the groundwater flow is an example of a laminar flow. So, laminar flow means the flow in which the particles move in layers. They move in layers and do not cross the path of other particles is known as a laminar flow. So, ਇਸ ਦੀ ਐਗਜ਼ਾਮਪਲ ਹੈਗੀਆਂ ਸਾਡੇ ਕੋਲ ਜੀ, ਜਿਸ ਤਰ੍ਹਾਂ ਕਿ ਕੈਪਿਲਰੀ ਟਿਊਬ ਦੇ ਵਿੱਚ ਲਿਕੁਇਡ ਫਲੋ ਕਰਦਾ ਹੈ ਜਾਂ ਗਰਾਊਂਡ ਵਾਟਰ ਫਲੋ ਸਾਡੇ ਕੋਲ ਐਗਜ਼ਾਮਪਲ ਹੈ ਲੈਮੀਨਰ ਫਲੋ ਦੀ. Then we come a turbulent flow. So, this is a conduit. So, this is a conduit and this is a conduit in which the particles they are moving just like this. They are not in layers, they are crossing each other. So, this is an example of a turbulent flow. The flow in which the fluid particles move in zigzag way, and do not move in layers and cross the path of the other particles. For example, high velocity flow in conduit pipe of large size will be a turbulent flow. So, turbulent flow means the pipe in which the liquid is not flowing in layers, they cross each other. At any point they cross each other, then this type of the flow is known as a turbulent flow. Means the flow in which fluid particles move in zigzag way and do not move in layers and cross the path of the other particles is known as a turbulent flow. Then we come compressible flow. The flow in which the density of the fluid changes from point to point, that is, density is not constant for the fluid flow. So, mathematically we can say density means rho. This is a symbol of rho, rho means density. So, mathematically we can say when density is not constant, these examples of gases are mostly compressible. So, compressible means the flow in which density of the fluid changes from point to point, that is density is not constant for the fluid flow, like this is the density rho which is not a constant, is known as the compressible flow. Then we come to the incompressible flow. So, incompressible means density is a constant. So, liquids are mostly incompressible is the example of incompressible. So, incompressible means the flow in which the density of the fluid does not change from point to point, that is density is constant for the fluid flow. So, that is known as the incompressible flow. So, incompressible means in which density of the fluid does not change from point to point is known as incompressible fluid. Means this is a density, symbol is rho, which is a constant value, is an example of liquids or the incompressible fluids. Then we come to the rotational and irrotational flow. So, this is a conduit in which the liquid is flowing and the particles, they are also moving in this way, that is known as the rotational. Then secondly, we will talk about the irrotational. This is a conduit, liquid is flowing, the particles, they do not rotate. So, in this case they rotate, in this case they do not rotate. So, rotational flow means the flow in which the fluid particles, they are flowing along the streamline and also rotate about their own axis, is known as rotational flow. So, rotational flow means the particles, they are moving in along the streamline, this is along the streamline. At the same time, they are also rotating, that is known as the rotational flow. Then we come to the irrotational. Irrotational means the flow in which the fluid particles do not rotate about their own axis, is an example of the irrotational flow. Then we come to the continuity equation of flow. So, continuity equation of the flow means the equation which represents that the weight of the liquid remains same at all the sections, provided no liquid is added or subtracted from the flowing liquid, is referred as the continuity equation of the flow. Let us consider a tapering pipe running full with water. Now, let us say that this is a tapering pipe. There are the two sections, section 1 and section 2. At this has a section at A1 having the velocity V1, this is the section 2 having the area A2 and the velocity V2. The velocity of the flow at above sections, if W is the weight of the liquid flowing per second, then we say by this continuity equation, small w multiplied by area of the section multiplied by the velocity of the flow is equal to weight of the liquid per unit, which is flowing per second, then area of the section and the velocity at the section 2. Since the liquid is the same, it has got the same density, it means that this is the weight flowing per unit is the same. Then we say these are the two constants, they are multiplied. Then we say A1 V1 is equal to A2 V2 is equal to the Q. So, V1 is equal to Q divided by A1, or we can say this V2 is equal to Q divided by A2, this is A2. Then we are getting to put in this equation and we find that this V1 is equal to A2 V2 divided by A1. This is known as the continuity of equation. Next we will take about the Bernoulli's theorem. So, this is a pipe having the section 1 and having the section 2. So, Bernoulli's equation state in a steady continuous flow, of a frictionless incompressible fluid, the sum of, there are three types of energies. One is known as the potential head, the second one is known as the pressure head, and the third one is known as the kinetic head. So, in a steady continuous flow of a frictionless incompressible fluid, the sum of the potential head, pressure head and connecting head is same at all the points. Now let us say this is section 1, this is the section 2. The three parameters of this potential head, pressure head and the velocity head, if we are getting to add all the three of the potential, pressure and the velocity head, means Z1 plus P1 divided by W plus V1 square divided by 2G is equal to Z2 plus P2 divided by W plus V2 square divided by 2G is equal to constant. Means the sections, they are the steady in a steady continuous flow of a frictional incompressible fluid, sum of the heads, three heads, that is the potential head, pressure head and connecting head remain the same. Then we make certain assumptions which they are: flow is ideal, incompressible, continuous and steady. The second one, flow is in one dimensional. The third one is flow has uniform velocity and forces acting on the fluid are pressure and gravity. So the flow is one dimensional, flow has uniform velocity and forces acting on this are pressure and the gravitational forces. The second, we are getting to deal with the flow measurements. So flow is measured for designing various hydraulic structures in terms of rate of the flow or discharge. For this purpose, we need velocity of the flow and the cross sectional area of the channel, and the this discharge is equal to multiple of the two factors, that is area and velocity. Flow are measured for various purposes. So इसके purpose क्या है, use क्या है for the flow measurement के, to make an accurate assessment of the available water resource. Second, for design of multi-purpose river valley projects, to plan for optimum utilization of the river water. Next is to distribute the available water in different canal systems. Next is issuing of flood warnings, on the basis of measured discharge at higher stages of a river. So these are the various advantages or various uses. Then we come to a next article, measurement of the average velocity of the flow. To determine the discharge flowing through a channel, the mean velocity, that is the average velocity of the flow, is required to be determined. It can be measured by the following methods. The first one is floats, the second one is current meter and the third one is pitot tube. So one by one we will read. The first we take about the float. Now float, what they are? Float is a small object made of wood or other suitable material which is lighter than water, thus capable of floating, and the floats are of the following types. The first one is single float or surface float. The second one is subsurface float or double float. The third one is rod float or the velocity rods. So one by one we will deal. First we are getting to deal with the single floats or the surface floats. Now what is they are? It may be a piece of wood or an empty bottle or a piece of the cork. The float is put on the free surface of the flowing water and time is noted after a known distance is covered. Now what is the function? We take a float, we put at one point, measure the distance and the time which is being noted. So means surface velocity, which is equal to distance travelled divided by time taken. A particular distance is covered in a specified time. So that the two ratios, distance travelled by the float divided by time taken to change from A to B by the float is noted and we take its ratio. So that ratio is known as the surface velocity. So the mean velocity of the flow is equal to 0.8 to 0.95 times the surface velocity. The surface velocity which we have calculated is multiplied by a factor 0.8 to 0.95, and that will give us the mean velocity. So mean velocity is found just like this. Now secondly, the subsurface float or the double floats. Now this is the example. Now let us take this one. So this is the liquid flowing having the depth, this is the bottom surface. There are two types of the float. First at the top, the second is being immersed, which is a hollow metallic sphere, and the liquid is flowing. So the second float is suspended at a distance of the depth is equal to 0.6 times the total depth. These two floats, they are connected by chain or by a cord. So this is the surface float. Now what is the subsurface or the double float? State that it consists of the two floats. It consists of the two floats. One is one, this is second. It consists of the two floats connected to each other by a chain or a rope. One of the floats moves on the free surface, while the other, which is heavier and is made of a hollow metallic sphere, is located at a depth of 0.6 times the total depth of the liquid, and the combined motion of both the floats give us the mean velocity of the flow. This method is suitable for finding the velocity of the flow in deep rivers. This is used for finding the mean velocity in the deep rivers and is not used for the shallow rivers. The rivers having the weed growth at the bottom. So at that places we cannot make. So in case of the shallow rivers, or rivers having the weed growth, we cannot find the exact values. So in that case, these two things are not required. We are getting to find in case of the deep rivers. Then we come, the third one float is a rod float or the velocity rod. So this is a rod having the depth of the liquid, this is the bottom, this is the top, this is a wooden rod, so which is being placed maximum to the bottom, maximum. This is the liquid type of the flowing from this point to this. Now what does it state? It consists of a vertical wooden rod which is weighted at the bottom to keep it vertical. The length of the rod is so adjusted that it reaches the bottom of the stream without touching the weeds. So at the bottom there may be certain weed growth, the rod should not touch this one. So we are getting to keep as near as per bottom, but at a distance of near about 0.9 times the depth. We keep certain this way by means of weighing at the bottom. The length of the rod is so adjusted, it reaches the bottom of the stream without touching the weeds, sand or mud at the bottom of the river, and its top should be above the water surface. Its top of this rod should be above the water level. The best results are obtained when the lower end moves closer the bottom and the depth of the immersion varies from 0.9 to 0.97 times the total depth of the liquid. The rod will travel with a velocity equal to the mean velocity of the time. So in this case, we take the 2 points. The third one is the current meter. So this is an example of a current meter. So liquid is flowing. So these are the cups. This is a conical cups. So this is a spindle along which they have been. So these are the wheel containing the blades, and these are the transmission leads of indicating units. These are the transmission leads. These two are the transmission leads to indicating units. So, we are getting to suspend this whole instrument is suspended from this by a suspension cable. This is a suspension cable. So, this is the tail. This is liquid is flowing from this, and this is the end point, that is the tail, and the whole instrument is balanced by a balancing wheel, Now, let us study. Now, let us study this one. So, it is an instrument used to measure the velocity of the flow at a required point in a flowing stream. It consists of a wheel having the blades or cups and tail on which the flat vane. The current meters, they are classified of two types. One is known as a cup type, the second one is known as a propeller type. The first one, cup type current meter. First one is cup type current meter. In this current meter, the wheel of the revolving element has the form of a series of conical cups mounted on the spindle, which held is vertically at right angle to the direction of the flow. It is suspended by means of the cable and is held vertical, immersed in the flowing stream of water to the required depth, such that the wheel of the revolving element is facing towards the upstream, and the cups rotate about the spindle due to the energy of the flowing water, and the speed of the rotation is proportional to the velocity of flow. An electrical current is passed from the battery to the wheel by means of a wire. A rotation of the wheel make and break the electrical circuit, which causes an electrical bell to ring. Thus, by counting the rings of the bell, rotation of the wheel, ultimately the velocity of the flowing water is obtained from the calibration chart, which is being provided by the manufacturer along with each of the current meter. The second one is a propeller type current meter. In this current meter, instead of the conical rotating cups, we provide propellers. So, conical wheels जो हमारे पास होते हैं पहले में, वो उसकी substitute है this type of the propeller के अंदर कि they have been provided with 2 or 4 vanes which rotate about a horizontal axis. The basic principle of working of the propeller type current meter is same as that of cup type current meter. In this also, we count the number of revolutions of the propeller by using an electrical make and break circuit. The method of suspension and other procedure remain the same as that of the cup type current meter. The cup type current meter is more preferred than the propeller type. Last we say as a pitted tube. Now, this is a pitted tube in which it is an instrument used to determine the velocity of the flow at the required point in a pipe or channel. It works on the principle that if the velocity of the flow at any point becomes 0, pressure there is increased due to the conversion of kinetic energy into pressure energy. It consists of a glass tube bent through 90 degree which ends on unsealed. One limb is called body is inserted into flowing stream, faces the direction of the flow, while the other limb called stem is vertical and open to the atmosphere. The liquid rises in the tube due to the pressure exerted by flowing liquid. So, this is a pitted tube. So, this is bent at 90 degree. This is the stem portion, this is the body, liquid is flowing. At this we say the head is changed from kinetic to a pressure. So, this is a pressure head. The theoretical velocity is equal to 2gh the under root, and the actual velocity is equal to the theoretical velocity multiplied by a coefficient of the velocity. So, this Cv is known as coefficient of velocity. If the theoretical velocity is multiplied by a factor Cv, which is a coefficient of velocity, then we can find the actual velocity. Let us take one question. A pitted tube was inserted in a pipe to measure the velocity of the water in it, if water rises in the tube approximately 150 mm, find the velocity of the water. Now, solution is the head of the water which is there, that is 150. 150 means 0.15 meter by this theoretical velocity, which is equal to 2gh the under root. We substitute its value, g is equal to 9.81. We multiplied the head is 0.15, take its under root and we calculate this value. So, that is 1.7115 meter per second. So, this is the answer. Then we come to notches. A notch is an opening provided in the side of a tank or vessel